Okay, Unit 6, the first section, 6.1, we're going to identify and classify polygons. We're going to find angle measures of quadrilaterals. So a polygon, note that these street signs, each is formed with straight lines. So a polygon is a figure that's formed by 3 or more segments. They're called sides. Okay? Each side intersects exactly 2 other sides at their endpoints, called a vertex. 2 vertices that are the endpoints of the same side are consecutive, so they go one right after the others, called consecutive. So P, Q, R, S, and T would be consecutive. R and S are consecutive, S and T consecutive, etc. If I join 2 non-consecutives, 2 that aren't side by side, that segment is called a diagonal. So in our example over here, RP and RT are diagonals. So we're going to identify the polygon, if it is a polygon, and explain our reasoning why it is or isn't. So in the first one, it is a polygon because we have 4 straight sides. But in letter B, it would not because of the curve. In C, it would not be a polygon because it's not a closed figure. It has to be a closed figure. And in D, yes, we have 6 straight sides. Once we know that it is a polygon, we can then classify it or name it by the type. So 3 sides are a triangle, 4 sides a quadrilateral, 5 sides a pentagon, 6 sides a hexagon, and 7 sides, we want to make sure that we call that a heptagon, not a septagon, a heptagon, and 8 sides an octagon. Another one that we can add to it is 10 sides, the decagon. And if we are greater than 10 or 9, we just call it an n-gon. So for instance, 17 sides would be called a 17-gon. So now we're going to classify, decide whether it's a polygon, and if so, what type or what classification or what name would you give it. And this is a general name from the classifications on the prior page. So the first one is a polygon, and it has 4 sides, which is a quadrilateral. B would be no, because we have curves. 6 is yes, and we have 5 sides, which is a pentagon. And D would be no, because we have this point in the middle that intersects more than 2 sides. I call that an overlap. It's not really the official. Official is that it intersects more than 2 sides. So in our checkpoint here, we decide whether the figure is a polygon. If so, what type? So you can try those on your own, then check your answers as you continue with the video. Okay, the assignment is attached. You can continue playing the video to get the day 2 notes or lesson. So I'm going to continue through the page where day 2 starts. Day 2 starts where we talk about the angle measures. If I take a quadrilateral and I draw a diagonal, it will split that quadrilateral into 2 triangles. Each triangle, the interior angles add up, or their sum is 180. So since I have 2 of them, then a quadrilateral must add up to 360. So let's find the angle measure of S. And it's okay if we just call it X. A quadrilateral sum must add up to 360. So you solve for X, and X equals 140. Okay, so continuing with finding the angle measures. Again, I don't mind if you call that a variable. And remember that all of them must add up to 360. So when I add 110 plus 60 plus 100, I get 270. Subtract that from 360, I get 90. And the next one, again, add them all up, must equal 360. When you add those up, 80 plus 55 plus 160, you get 295. Subtract that from 360 and you get 65. And the last one, again, add them all up. 72 plus 108 plus 108 is 288. Must all add up to 360. Subtract 288 from 360 and you get 72. So how do you know that this figure is a polygon? First, it's closed. We have 4 segments or straight sides, and each only intersects two other segments. Okay, so the assignment is attached. This part, I do want to just come down here to this and let you know you still add and equals 360. Even when you have an expression, make sure a right angle that you don't forget to put the 90, and you will still just add equal to 360 and then solve for X. So you're going to create more of an equation and then solve for the variable. And this ends 6-1.